In these notes, we're going to be looking at arithmetic sequences. So notice the first question we have is, what is an arithmetic sequence? So an arithmetic sequence, it is a sequence of numbers such that the difference between the consecutive terms is constant, referred to as the common difference, and represented by D. Now, when we talk about how do I find the common difference? Well, to find the common difference, subtract any two terms that are next to each other, right to left. It is very important that you go from right to left. And let me show you what I mean. So if I take the term 15, which is next to the term 13, then I'm going to go ahead and I'm going to put the one on the right on top, the one on the to the left on bottom, and I'm going to subtract them. So I have 15 minus 13, and that will give me 2. Now, just to go ahead and confirm that this is an arithmetic sequence, I'm going to go ahead and do that same process to every one of these. So now I'll subtract from right to left. 15 from 17. Right number goes on top, left number goes on bottom. Once again, it gives me 2. Then I'm going to take 19 and subtract 17. And it gives me 2. So I want you to notice that when we're looking at this, I have the same number that keeps reoccurring. And that tells me that every time we have a sequence, it just increases by positive 2. That means that my common difference is therefore 2. So this has confirmed that this is an arithmetic sequence and that I have a common difference of 2. Notice that it does not matter which two terms you pick, it is always the same. If it gave us more terms, we could continue this process and it would always show a change of positive 2. Now, knowing that, we're going to go to the next part of our lesson, which is write the first 5 terms of the arithmetic sequence in which a sub 1, and I'm going to box that, is equal to 4, and d is equal to 5. So I'm going to write my a sub 1 right here, and that's going to be equal to 4. And so I want to do 5 terms, so what I'm going to have is a sub 2, a sub 3, a sub 4, and a sub 5 when I'm done. So we're going to write 5 terms. We can also refer to this as 5 sequences of this number pattern. Now, since I know my common difference is a positive 5, remember up here, if it was a positive 2, notice they just simply add 2 for each sequence. Down here, if it's a 5, we just need to add 5 for each sequence. And so I'll show you, I'll work each one of these out. My a sub 1 was 4, and so if I add 5, that's going to give me 9. So my a sub 2 is 9. If I take that 9 and I add 5, then that's going to give me my a sub 3, which is going to be 14. If I take that 14 and I add 5, then it's going to give me 19, and a sub 4 will be 19. And then if I go ahead and take that 19 and I add 5, that's going to give me 24. So my a sub 5 is 24. Now you may be looking at this going, Mr. Helbert, I don't really understand what the purpose of this is. We can all add numbers very easily, and what would be the purpose of me just adding numbers to give you all these different terms? Well, that's a good question. And the reason this is important is because what if you wanted the 500th term? Can you imagine having to add 500 different times to try to figure out what the answer was? Well, I'm going to show you next. We're going to be looking at another sequence. We're going to practice one more of these. And next one I'm going to show you is how to use what we call an explicit formula or a recursive formula to determine what any term is, no matter how far out. It could be 956,000th term, and we can determine with a formula exactly what the value would be but I just wanted you to understand that this is actually what's occurring when we use the formula. The formula is just a shortcut way to get to a very high term, or high sequence number. So let's go ahead and move on to the next part. We're just going to practice this one more time. Notice that your a sub 1 is 3 over 4, and a sub 1 is where we started. And then notice that over here the common difference is 1 over 4. So let's go ahead and write these out. And we want to do the first 5 terms. So we're going to have a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Now my common difference is 1/4. So notice that my a sub 1 is 3 over 4. So if I write that over here, okay, I have 3 over 4. And if I add a positive 1/4, that's going to give me 4/4, which is just equal to 1. So a sub 2 is going to be positive 1. If I go ahead to do a sub 3, I'm going to take 1, or I'll leave it as a fractional form because I think it's easier to do it that way, 4 over 4. And I'm going to go ahead and add another 4th, which will give me 5/4. So a sub 3 is 5 over 4. And if I take that 5/4 and I add another 1/4, that's going to give me 6/4. Or if we recognize that this can be simplified, we could say, well, 2 can go into 6 3 times, and 2 can go into 4 2 times, which is 3 over 2. And then we can go ahead and do it one more time, and we can say our 6 over 4. And if you're wondering why are you using 6 over 4 instead of 3 over 2, and it's because it's just easier because they have a common denominator for me to do the adding if I keep it at 6 over 4. And that would give me 7 over 4. And that would be a sub 5. Now, you can imagine that with fractional values, it's a little bit more difficult to do this arithmetic sequence, so having the formula makes it way easier. So we see how to do it by hand, how to find our different sequences, or our terms. And so now let's go ahead and take a look at what the formula looks like and what each one of these, you heard me saying a sub 1, but let me explain a little bit more of how we say it and what it is. So move your notes up. Notice it says, what is the arithmetic sequence formula and what does each variable represent? Well, here's my formula. I have a sub n is equal to d times n minus 1 plus a sub 1. Now when I say a sub n, I am actually saying a, the word sub, and then the letter n. So when I say a sub n, and if you're like, well, and if you're wondering, if you're going, Mr. H, why do we say a sub n? Where does that come from? Well, notice that this n is a little n, and it's kind of down at the bottom of that variable. And when we see that letter down there, and it's at the very bottom, we call that a subscript. But instead of saying a subscript n, we just say in short a sub n. So just keep that in mind to help you remember. It's a sub n. So a sub n, and what this represents, a sub n, and that's this part of the equation, it represents the general term. So general term. Now this other one, the way we say this is a sub 1. So a sub 1, and a sub 1 is this term right at the end that we're adding. And when we talk about a sub 1, it represents the first term in the sequence. Then we have this d. We've already talked about it a little bit. It's right here at the beginning of the formula, being multiplied to the n minus 1, and that represents the common difference. That's just the amount that it changes, that's added or subtracted each time. Then we have n, and n just represents the number of terms, or sometimes we call it sequence. So now you know what every letter stands for with this formula, and you see the formula. So now what I want to do is I want to go ahead and use it on a problem and just show you how it's helpful, how we can keep from having to manually add or subtract some value over and over and over again. We can just use the formula and we can find the term right away. So notice it says, how can I use the formula to find the nth term in a series? Okay, well, let's go ahead and do that. Notice this says use the formula for the general nth term of an arithmetic sequence to find the sixth term of the sequence with a sub 1 is equal to 155 and the common difference is 12. Now notice I did box these just as we box them when we're doing any word problem, and now we're going to go ahead and put this formula into action. So let's go ahead and see. So on this one right here, I have a sub n is equal to d times n minus 1 plus a sub 1. Alright, so what I'm going to do, I'm going to go ahead and start replacing my variables with the values that they're represented by. So for instance, when it comes to d, this is equal to my common difference, which is 12. So I'm going to put a 12 in parentheses. And remember, anytime we're replacing a variable with a number, we just put it in parentheses. And I'm going to go and put my other parenthesis, and now I want to go ahead and put my n down here. Now the n, remember, it's the nth term, and it told us they want us to find it for the sixth term. So I'm actually going to put a 6 minus 1, close parenthesis, and now I just need to add my a sub 1. Well, my a sub 1 was 155, so I'm going to add that at the end. Now, in all honesty, I didn't bring down this a sub n, but if I do, we are no longer looking, we know what n is now, right? So it's not a sub n anymore, we're looking for a sub 6. That's the one we're trying to find. Notice the n changed to a 6, and this n changed to a 6. So now we have this all written out, and we just need to do the math, and we'll have our answer. So a sub 6, which is the sixth term, is going to be equal to, so I'm going to put this in my calculator, just as it looks. I'm going to use my parentheses. So I have my common difference, which is 12, and then that's times 6 minus 1 and plus 155. And yes, technically we did replace that a sub 1, so we could have it in parentheses, but since it's at the end, it won't make a difference. I just like y'all being in the habit of using your parentheses. So if I go ahead and I hit enter, it gives me 215. So I'm going to write that down, 2, 1, and 5. And that is our answer. Without having to do them one at a time, I got my answer, and it's 215. Now, just for grins on this one, I want to go ahead and work this out by hand, just to confirm that this formula actually works, right? Because there's nothing better than proving that the formula works by doing some hard work. So let's go ahead and look at what our a sub 1 is. So I got a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. So we're going to do some manual work here. We're going to do it the way that I first showed you. Notice our common difference is 12. So my a sub 1, we know that that's 155. So we know our a sub 2 should be 155 plus 12, which would end up giving me, right, we'll prove that I'm correct. We'll use my calculator, keep me real accurate right here. So watch this, 155 plus 12, hit enter, there is 167. Okay, so I'm going to write it down, 167. 167. And then now we have 167 plus 12, which would give me, and all I'm going to do is here is just put plus 12. That's just adding it to my current answer. And that's going to give me 179. So 179. So this is 179. Then I'm going to do a sub 4, which is going to be 179 plus 12. So we'll just add another 12 to it, and it gives me 191. So a sub 4 is 191. And then we have 191 plus 12. And if I put that in my calculator, I'm just going to add another 12 to the sequence. We have 203. So this becomes 203. And if we do our last one, we have 203 plus 12. And if I add one more 12, I'm just going to hit plus, and then 12. It gives me 215. I'm going to write 215. Notice, no matter which way we got the answer, they're both the same. But I want you to imagine for a second, what if they told you they want you to find the 856th term? Right? That would be a whole lot of work with this. But with this, it would be really easy, right? Because you would just put 856 right here, and you would put 856 right here, and you would have your answer.